Hello, it's Keith here, and this is lesson 4 of the SuckShoot series of my 8086 assembly programming tutorials. We're back for an unexpected suck with SuckShoot, because I originally wrote this game for VGA and I didn't really think I was going to have time to take it any further than that. But I'm a big fan of the old CGA look, because I actually had a CGA machine back in the day, although strangely it was black and white, so I don't know why I enjoy the CGA colours so much, but I do. And so I thought it was a good opportunity to take another look and port the game to CGA. So we got the game once again here, and we've now got our cursor in Glorious, or if you can call CGA Glorious, in CGA colours. So that is magenta, cyan and white, which is the best of the two CGA palettes in my opinion. So the game works exactly the same as usual. We've just had to reprogram it to use the CGA graphics, and that's what we're going to be looking at today. Now, contrary to popular belief, I didn't hire the world's best graphics artist to do the graphics for me. I actually did them in Sprite Editor by myself, and so we've had to convert the colors of our graphics obviously into CGA, and then we've had to export them with the 8086 option. Where is it? Here it is, x86, MS-DOS, save all bitmap CGA, and I had to rewrite the code a little bit to support multiple sprites and things. So we've had to export the sprites into a different format for today's example, but thanks to a few changes in the code, our game now works in fantastic CGA. So let's take a look at the code and let's see what's been changed. Okay. So most of the code is basically the same. Things like joystick reading, the sound drivers, they haven't changed, but what has changed is the graphics routines. So at the start of our program now, we've got these new int 10 calls here, and these are to select the video mode here, and then we are selecting the color palette here, and so on. We're just then setting the brightness here. So we've got these three int 10 calls here, which are setting up the colors. And if we were feeling creative, we could change from the cool colors, we could change the warm colors. If we change this to a 0 and then we run again, we should get a different color palette. There we go. So now we've got those colors. Although personally, I do enjoy the cyan magenta palette far more. The lack of the white is a bit disappointing. So we can change the colors if we feel like it. Now, the first thing we're going to have a look at that's changed is the CLS routine. Now, of course, unsurprisingly, the 16 color mode and the 4 color CGA mode work very differently in terms of memory mapping. And so we need to go to a different memory segment for our video memory. We go to B800, and the amount of memory we need to clear is different. We're going to do 4000 in hexadecimal, and that's 320 by 200 divided by 4, because there's 4 pixels per byte in this mode. And we're using STOSB to store zeros repeatedly to the memory range, and that will clear the screen. That's effectively wiping our screen. Now, as well as clearing the screen, we're going to have to actually put things back onto it. And we've used a print char routine to do this for us. Now, this is my little simple bitmap printing routine, which uses a 1 bit per pixel font. Now, our source font is 1 bit per pixel, but our destination screen is 2 bits per pixel. So we're going to have to do a little bit of bit shifting to fill out each line. Now, the problem with the 8086 screen in CGA mode is the memory layout. Alternate lines are basically interlaced at 2 different memory addresses, which is rather a pain. And so what we've got here is we've got a line called print char do pair, which does a pair of bytes to the screen, and that's effectively 1 line of our font. And then what we're doing is we're doing basically the first line of our font. We're then adding 2000 in hexadecimal to the destination memory address. We're then running that again, and then we're subtracting 2000, moving back between the 2 banks that make up the alternate lines of our screen. Now, the print char do pair routine is pretty simple. All we're doing is we are basically moving 2 bytes from our source to our destination here, and we're basically bit shifting 4 bits out of our source font into our destination byte that we're going to transfer to the screen. And as I say, that's because we're converting from a 1 bit per pixel source font to a 2 bit per pixel screen destination. So a little bit of a faff going on there. The other thing that's a little bit of a faff is calculating the destination memory address for our screen, and also calculating the offset within our font. Now, our font itself has no characters below 32, so we subtract 32. There's 8 bytes per font character because the font is 8 by 8 pixels, and as I say, there's 1 bit per pixel, so 1 character is 8 bytes. So we're just compensating for that. And then what we're having to do here is we're having to effectively calculate the offset within our screen destination. Now, there are 40 characters on our line, and our characters are 8 lines tall, and there's 2 bytes per character, but because lines are interlaced at 2 different memory addresses, we are actually, to calculate the offset in the first bank, instead of 40 times 8 times 2, we're doing 40 times 4 times 2, and that is the amount of bytes basically in one strip of our character blocks to calculate the position within the first bank. And so we're multiplying that by the character Y position. We're then taking the character X position here, and we're just multiplying that by 2 because there's 2 bytes per character, because as I say, there's 4 pixels per byte and there's 8 pixels per character. So we're just calculating that offset there, and that's calculating the destination within our memory of our character that we want to show. Now, we've got here our sprites. These are the sprite data that I exported from Accurate Sprite Editor in glorious CGA. And there's our sprite info table here, which is the offsets within that for all of our sprites. Now, this is basically the same as the VGA. The only difference is the pixels per byte is now 4 pixels per byte rather than 1. And that is altering the calculations here for calculating the correct offset for each sprite. Now, I'm not going to go into too much detail about the sprite info and how that works, because if you want to see that, please see the VGA example. Basically, when we are drawing a sprite to the screen, we're calculating an offset within the sprite info table, and then we're getting the width and the height of our sprite from that table in pixels. We're then converting that to a number of bytes, and we're shifting our screen destination so that the past X and Y coordinate for our sprite is actually the center of the sprite, not the top left corner that we draw from. And the reason we're doing that is so that the range checking is working from the center. So basically, we are converting our number, our height into, we're halving that, and then we're subtracting that from our draw Y. With our draw X, we're shifting it to the right twice to convert it to a number of screen bytes from pixels, and then we're shifting it to the right one more time to convert it to a number of bytes, so that when we calculate our destination, it will come out right. Now, another tricky thing we're having to do is with our Y position. We are, as you can see here, we're masking out the bottom bit of our Y line here, and the reason we're doing that is, as I said before, the screen offset is actually different for odd and even lines. So basically, we are calculating the base here, and then we are testing the bottom bit of our Y line, and we are basically adding hexadecimal 2000 to the destination for odd lines. So that is calculating the starting draw position, and then we're transferring all of the bytes of our line of the sprite here, and then after each line, what we're doing here is we're testing to see if we're on an odd or even line, and if we are already in the second bank, then we are adding 80 and moving back to the first bank. But if we're still in the first bank, we are just adding hexadecimal 2000 to switch into the second bank before we add 80. So we're only adding 80 to move down a line within the bank every 2 lines, because for the alternate lines, we are actually having to switch to the second bank there. And that is drawing our sprite to the screen there. It's a little bit of a pain there, but that's what we have to do to cope with the interlaced screen layout. And anyway, that's basically all we have to do to get this to work with our CGA screen. Now, the joystick routines and the sound routines, they've all been covered in the past in the simple series and the platform specific series. So if you want to see how those work, please take a look at those. Anyway, if you like what you've seen, please like and subscribe. If you like the videos, YouTube recommends them to more people, and I make more videos. And if you subscribe, you get to see all the fantastic content that I've got planned in the future, or at least all of the vaguely acceptable content I've got planned in the future, because some of it's not so fantastic, I guess. Anyway, I hope you've enjoyed this today. Anyway, thanks for watching, and goodbye.